Let us continue. Page number 5. We saw the force between the two charges when placed in air or vacuum. This is the formula. It is observed if the charges are placed in any other medium, maybe water, maybe a liquid, maybe anything, in any other medium, the force is going to be less. What is our observation? Force between the charges reduces in a medium. Then automatically your question comes, why it happens? It happens due to some electric property we call electric polarization. What is electric polarization? That you will study in chapter number 2. So we will not discuss that now. Electric polarization. So come to the fact, when you do the experiments, force between the two charges always is found to be less. Less by how much amount? It is observed force between the charges becomes F upon K, where F is the force in vacuum, then it will become K, where K is a constant. Name given to K is dielectric constant. So what do you mean by dielectric constant? It is a constant of the medium, just like the density of a substance, just like the refractive index of a material, or maybe just like velocity of light in a medium, etc. It is a constant. Details we come across in the coming parts of the chapter. Now, what are the values of K? By definition, K is going to be 1 for vacuum. If it is going to be vacuum, force K is going to be 1. K is almost 1 for air also. So most of the problem will be solving for air or vacuum with medium, then our K doesn't come at all. Any other medium, K greater than 1. So what is the dielectric constant? Dielectric constant is more than 1, just like our refractive index. When we study light, we see refractive index is 1 for air or vacuum. Any other medium, it is more than 1. Similarly, K is more than 1 for any other medium. Can we give some examples? We will see K is going to be some, let us say, 16 for germanium. What does it mean? It means, if I consider the example, the force between the two charges in vacuum is 1 Newton, then what will be force in germanium? Force in germanium will be F upon K, that means 1 upon 16 Newton. It becomes K for water is going to be 81. We don't have to remember example. So what will be the force between the charges when I place in water? F in water will be, most of us got the answer, 1 upon 81 Newton. So this formula is valid only for air or vacuum. What will be for any other medium? Then this epsilon 0, or whether it is simple, in the equation epsilon 0 must be replaced by K epsilon 0. What is that? To get the equation applied for any other medium other than air or vacuum, Coulomb's law in any other medium, epsilon 0 becomes K epsilon 0. So our equation will become 1 upon 4 pi K epsilon 0, 1 upon 4 pi K epsilon 0 if it is any other medium. So what is going to be Coulomb's law when it is applied to any other medium? If it is 1 upon 4 pi K epsilon 0 Q1 Q2 upon R squared. What is K? Dielectric constant of the medium. What is mean by that? It is a constant of the material. Can you give some example? The values we have mentioned. So conclusion, what is K? Our equation is K equal to force in vacuum divided by force in the medium. Force between two charges in vacuum will be more, force in the medium will be less. So from here, what is the force in the medium? F vacuum upon K. So two equations we have just, the Coulomb's law applied to any other medium, 1 upon 4 pi K epsilon 0 Q1 Q2 upon R squared. Then confusion comes. Somebody may think, there is no confusion, which formula I must use? This is the most general formula. In the problem, if it is going to be air or vacuum, that is 90% problem, then K will be 1, formula will be 1 upon 4 pi epsilon 0 only. What is the value of 1 upon 4 pi epsilon 0? 9 into 10 raised to 9. Q1 Q2 upon R square. What is the value of K? K is F vacuum upon F medium. One more point. For a metal, K for a metal is going to be infinite. So can we say what will be the force between the two charges in a metal? Is it 0 or is it infinity? Let us try. K is going to be F vacuum upon F medium. So F medium will be, F metal will be, F medium is F vacuum upon K. In this case, F vacuum upon K is going to be infinite. Everybody knows anything divided by infinity is what? Anything divided by infinity is 0. So what is the force between two charges in vacuum? Is going to be 0. So two things we mentioned. Let us sum up. The force between two charges is maximum in air or vacuum. Any other medium it is less, equal to force in vacuum divided by K. Force in vacuum divided by K. It is a constant for the material. For air or vacuum it is going to be 1. For any other medium it is going to be more than 1. In the case of metal, K is going to be infinite. So F vacuum upon infinite is going to be 0. Then one example where we can utilize this first formula. F is 1 upon 4 pi epsilon 0 Q1 Q2 upon R square. That example is illustrated just in our notes, just page number 5, middle of the page, example is given. He says force between two charges Q1 and Q2 separated by a distance R is going to be F. The question is, you can go through that question and the answer is also given. I will explain that. What is the force between them? If the charge becomes half, this is half, this force also is becoming half, and our distance R also becomes half. The question is, what happens if the charge becomes half, dq1 is half, cu2 is half, and distance R also is half? Use our formula. This is the F in the initial case. What is the new force? Equal to, I write 1 upon 4 pi epsilon 0 Q1 Q2. That means 2 times Q1 into 2 times Q2 if it is doubled. But now it is not doubled, it is half. So I must write Q1 upon 2 into Q2 upon 2. It is not double, it is half. The whole divided by distance also becomes half. R by 2 square. So what will be the new force? 1 upon 4 pi epsilon 0 Q1 Q2 upon 4 into denominator is R square by 4. This 4 and 4 cancels, that will happen to be F. So when the charges become half and the distance also becomes half, what is going to be the new force? It is going to be same. The same force is there. Finally, just one example. Exactly the same way. That is the solution. Answer is given there. Suppose the charges are double and distance also is double. Can we get the answer? Q becomes double. Q1, Q2 becomes doubled, and R also becomes doubled. Can we find the force? Repeat, the question is, two charges are separated by a distance R. The force between them, we assume it is air only. Force between them is going to be F. What is the force when the charges are double and distance is double? Can we work out? Our answer will be same. Same means F only. How it is? We illustrate that. New force will be, similar problem, we will be able to follow 1 upon 4 pi epsilon 0, that 2 times Q1 into 2 times Q2 divided by distance also is 2R the whole square. That means 1 upon 4 pi epsilon 0 for Q1, Q2 upon 4 r square. 4 and 4 cancels. So it is going to be F. So it is going to be same. So in this example also, the force remains same. Don't be confused. In all such problems, don't say no change. F is the force. So we can apply the formula in such situations. So we sum up. We introduce the force in a medium. Epsilon 0 must be replaced by K epsilon 0. It is valid. And then this formula in some terms we are able to apply. We continue next time. Thanks.